What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to
Looking ahead, the attempt to play in two classes at once, and also to capture the audience of luxury cars, failed. Sales were very bad. The car slipped to the 5th or 6th place in the class, although the last generation in some years led in sales and kept in the top 3. Neither very spacious for this class interior, in insignia it is noticeably narrower, nor good passive safety, nor excellent choice of options, nor huge line of motors helped. The reputation was spoiled also by problems on an electric part, about which it will be told below. Technic structurally, the car is quite traditional for European manufacturers of these years. The body is completely steel, except for the aluminum hood. Motors are located transversely, drive on the front axle. The platform allowed to make all-wheel drive cars, but it did not go further than presentations. Suspensions, McPherson in front, Multilink rear. Controllable shock absorbers EDC are available as an option. Two variants of wheelbase, station wagon and Signum hatch, received 130mm addition, which are used to improve living conditions for rear row passengers. Among the motors, in addition to inline-4s, there are V6, and not only gasoline, but also diesel. The gearboxes are 5 and 6-speed automatic transmissions and 5-speed hydromechanical automatics Aisin series AW55-51/55-50, as well as robotized automatic transmission with one clutch, the infamous EasyTronic. There was also a Variator VT20, but only in theory. It is unreal to meet such a car on sale. In general, there seemed to be a lot of variants, but completions were strange. Weak motors did not have normal automatic transmissions, only robotized. There were no automatics and turbo engines 2.0. As a result, those who wanted a car with automatic transmission had to choose between not very successful motors 2.2 and excessively powerful and expensive in operation 3.2 and 2.8 turbo. But the car was quite well packed with electronics and became the first Opel project with a full hub architecture and extensive use of multiplex wiring. It also had quite a few very nice options, including adaptive AFL lighting that could illuminate turns. Timeline March 2002. The model is presented at the Geneva Motor Show. April 2002. Start of sales in Germany. So far only in sedan body. Motors are gasoline 1 8Z18XE 125 horsepower, 2 2-litre Z22SE 147 horsepower and 3 2-litre Z32SE 211 horsepower, as well as diesel 2 0 DTI Y20 DTH 100 horsepower and 2 DTI Y22 DTR 125 horsepower. The 2.2 and 3.2 motors are available with a 5-speed automatic transmission, while the others are only available with an automatic transmission. September 2002. Start of sales of hatchback version, Signum. May 2003. Appearance in the lineup of cars with 2.0 turbo 170 horsepower. Z20 net with automatic transmission, only for hatchback. October 2003. Beginning of sales of cars with station wagon body and versions with top diesel engine 3.0 Y30 DT 177 horsepower. There was also a version of 2.2-litre engine Z22YH with direct injection with 155 horsepower. March 2004. Small facelift. Changes on electronics, updates of equipment. Diesel engines 2.0 replaced by new series 1.9 CDTI Z19 DT 120 horsepower and Z19 DTH 150 horsepower. The latter is available with an automatic transmission. 4 gasoline motors 1.8 became available robot. The 2.2-litre Z22 SE engine is no longer available. September 2004. Release of the most budget version of the car with 1.6 Z16 XE 100 horsepower engine. Only in sedan and hatchback bodies. June 2005. Restyling of the model. New optics, interior design, and equipment. Almost all engines were updated. Engine 1.6 was replaced by Z16 XEP version with phaser regulator with an output of 105 horsepower. Engine 1.8Z18 XER also received phasix, and the power has risen to 140 horsepower. The 3.2-litre engine was removed from production. It was replaced by a new 2.8 turbocharged engine in versions Z28 NEL and net. 230 horsepower, Z28 net 250-255 HP and Z28 net Z28H 280 horsepower. The youngest 1.9 100 horsepower diesel appeared, Z19 DTL, and the 3-litre diesel was replaced by the Z30 DT version with an output of 184 horsepower. With 280 horsepower engine is presented sporty version of Vectra OPC with prepared suspension and special color of body and interior. Also presented are OPC line models, with OPC bodywork, but with conventional motors and slightly modified suspension and optics. July 2008. End of production. Body exterior panels. This is just the case, when proverbs about Opel absolutely do not apply. Because Vectra C rot really slowly, much slower than Vectra A and Vectra B or some Mercedes-Benz W210. However, taking into account the age of the car, the second-hand copy will not do without problem places. And the model still has some sins. Let's start with the most unpleasant. The lower door seal here is realized by one big molding on a steel frame, and it is fixed in the threshold holes just above the plastic cover. In fact, the problem is the same as with the Vectra B, but here the steel is galvanized, and therefore moisture and sand collecting. Under the rubber band, constant loads and movement when opening the doors lead to visible problems by 15 years, and not by 6 to 8 years, as in the last generation. Sometimes problems appear even earlier, but usually it is a consequence of accumulation of a large amount of dirt under the plastic, and inside the sill or damage to the paintwork in the past. The sill itself below is usually intact and only suffers badly if the molding mounting holes are depressurized. They're serious. Accumulations of dirt or the plug inside the rear arch has fallen out. There is also damage in the car service stations and tire shop. From them suffer mainly the lower rib and the seam of the sill reinforcer. The rear arch lip is another traditional headache. It rusts slowly but surely. The edge is not covered with anything. There is no film or plastic cover, so chipping is almost inevitable. The seam with the inner arch is literally a few centimeters on the inner surface, although moisture does not collect in the bolt. If you paint the chips in time, there will be no problems, but most of the owners do not bother and wait until the corrosion appears. On the outer surface, the inner seam rots, and at the same time the layer of zinc comes off from the entire fender panel. As a result of such care, the edge will have to be welded sooner or later. The front edge of the roof over the windshield rots decently. There is neither galvanizing nor large molding. Sandblasting often damages paintwork, and owners, again, do not bother with cosmetic repairs. The side and rear doors like to get bug corrosion on the outer panel. The reason is the specific aerodynamics and consequent chipping, as well as corrosion of the inner seam, which should be anti-corroded in a good way. Over time, the zinc goes away, and bugs become a lot. And the door moldings are not made in the best way. The clips have little mobility, damaging the paintwork in the holes. So under the upper molding at a glass traces of small corrosion are often visible. On the trunk lid and rear door of station wagons and hatchbacks, there is often also a small corrosion in places of contact of overlays with metal. The aluminum hood also usually has a lot of chips on the front edge, but otherwise it is not a problem. Its armature and frame are not corroded. Under door handles usually have a lot of scratches. Paintwork in this area, alas, is only slightly thicker and stronger than in Japanese cars. In general, the thickness of coloring is acceptable, quality of coating is also acceptable, so with proper care it can be kept in good condition even at the age of 15 plus. From below on an elevator, evaluate already mentioned above inner seam of a rear arch, and at the same time all internal surfaces. The lockers here are very tentative. The front wall is not really protected, and the seams and the sill plug remain a very vulnerable part of the body. You should also inspect the shock absorber mounting point very carefully, especially if there are traces of leakage of the shock absorber itself. In this case, the load on the body is greatly increased. It is desirable to inspect the cavity under the sill plates in the rear part. Dirt accumulates there, and severe corrosion may develop. The plates are fixed on 12 pistons. It is unreal to take them out on someone else's car, but in the rear part you can carefully pull the sill towards yourself under the rear edge of the door and look into the gap. It is quite good if there will be a compressor to blow out the cavity to remove dirt and assess the condition of the metal. From the front under the plastic you can try to see the state of the lower part of the front fender. There is also often an invisible, from the outside, pockets of corrosion. The age of the car does not greatly affect the condition of the sills. More important is the presence or absence of anti-car and how often and thoroughly wash the car. The underbody of most cars is intact, but it is worth scrutinizing the area around the drain plugs. They are obviously planted without additional treatment, so the plugs are rotten all around. Brake tubes are often all blown by 10 years of age, so brake fluid leaks are only a matter of time. Very rusty subframe brackets and heat shield mounting bolts are another characteristic of the model. On the last generation, the woes were similar. Usually there is a little rust on the body surfaces in the fuel tank niche and on the edges of the wheel arches, as well as under the trunk panel. Not much mastic here, but the rust is shallow, superficial. On the oldest cars may be rotten seams of floor spars, especially in places of contact with the ground and at the jacks. But in general, usually the condition of the car from below is quite acceptable. Since the VIN is located on the floor panel under the front passenger seat, the interior inspection from inside is obligatory. Wet floors are definitely a reason for a serious inspection with lifting carpets. But even if they are dry, you should not relax. The VIN itself often rots, if it has already been cleaned once, and the areas of the seams of the seat brackets and the transverse box of the cabin often have corrosion even in cars with a normal dry interior. The usual condensation and a little soaking in winter is enough to form the first rust points, but thanks to zinc, there are no badly rotten floors. In the trunk of station wagons and hatchbacks, you also need to control the floors, especially in humid regions. They often get wet after heavy rains, as the drainage of the opening is not well organized. Body equipment disappointment in the quality of Opel usually comes from various trifles. There are a lot of these troubles here, because the big car is actually quite budget in terms of solutions. Inexpensive plastic, economy on fastenings and manufacturers' focus on simplicity of design make themselves known. Microswitches in locks fail, motors with time go out of order, especially motor of drive of lock of a back door and a lid of the trunk. Skids of bumpers are fragile as on Frenchmen. A trapezium of wipers sours easily and casually. They put bushings from hover. Gas stops serve 10 years and begin to fail. Corrodes the aluminum base of the mirrors, causing problems with souring of the mechanism and simply losing appearance. Headlight mounts are weak. Good thing there are repair ones. The lens modules on the pre-steel are dead on literally all cars. On the Restyle, almost all of them. Fortunately, in the disassembly of the headlight is not so difficult, and there are new glasses for it too. Headlight corrector fails mainly because of weak body position sensors. Their tightness is 0. The turn signal repeaters are also leaky. The repeaters bulbs are fraying. There are problems with the contacts and the rear switching unit. The tank mounting straps are rotten and torn. After 10 years there may be surprises, especially when removing the tank. It is necessary to change the antenna seals on the roof. Water gets inside through them. Also, if the mileage exceeds 200, especially if the car is used in the city, it is better to change not only the doorstops, but also the driver's door seal. Separately, it is necessary to pass on a design of window elevators. They are lever, thorough, but cars with broken glass guide and its skew are often found. The motor is powerful, and if the guide wedges, it simply crumples levers. The trouble is that the mechanism is riveted to the door, so to disassemble and remove it is a non-trivial task. Even just change the guide is difficult. It requires skills of a proctologist in work with a Dremel. As a result, a penny problem is solved for a long time and expensively, so check the work of window elevators from the front. In general, there will be a lot of problems on the part of small equipment. Almost all of them are inexpensive, but can riddled with nerves. Detail original price of non-original 2 body parts front headlight 29,521 Valeo 15,467 TYC 8,137 front. Headlight Xenon 44064 Valeo 27,190 windshield 46,838 Spectre 4,353 Vendor 5,312 front fender 10,571 body parts 7,956 Polestar 9,268 front. Bumper 37,584 Polestar 14,769 Hood 85,217 body parts 12,762 TYG 11,122 Interior. The interior of Vectra C is very spacious, especially by the standards of D-Class of the early noughties. Quality of finishing is not bad. At mileage up to 200,000 the interior keeps exemplary look, giving out age only by shine of steering wheel and door handles. On the cars with MKP, the cover of a lever of a box still appreciably ages. And almost always the floor carpet gets very greasy. It does not like dirt very much here. On versions with combined interior, lining the sides of a driver's seat are strongly wiped. If the seats are all fabric, then only under the heaviest drivers with mileage over 200 the seams of the driver's seat on the left side and the edge of the backrest roll begin to give up. Unfortunately, again there are enough small typical breakdowns. For example, a broken armrest lock. Displays CID and GID are not distinguished by the durability of backlighting. A miniature fluorescent lamp of a very rare and expensive size, as well as display loops and soldering of original mags on the buttons. The multimedia system firmware regularly falls off, and, inconveniently, all the work is tied to the car passcode, which will have to be ordered from the dealer if the previous owner does not know it, or pulled out of the display of magnet a dashboard using a programmer. Typical breakdowns also include failures of the climate control unit, both manual and automatic. First of all, it is a breakdown of the central button. It stops pressing or reacting to rotation. This is usually treated by soldering the board, because one, or several at once, of 5 contacts of the multi-switch encoder is soldered off. The switch itself is rarely broken. The left switch often fails too. There are soldering problems there too. The 4 MHz resonator fails just as often, and the climate simply does not work in this case. Interestingly, the climate blocks on the restyling and pre-restyling are not compatible, but they have exactly the same problems. In addition to purely electrical problems, the air conditioning tubes corrode to the point of fistulas. It looks like they saved money on the material. It happens especially often with the lower tube under the condenser, and the fan motor likes to give a voice. Occasionally, the control unit fails, but this is usually a secondary problem, when the motor is already jammed. The problem is eliminated by replacing the transistor in the block. Breakdowns of the steering switches are tied to the CIM unit, and therefore it is logical to consider them in the next section. Electric's quite a few complaints about the electronics of pre-2004 cars have been eliminated on later cars. But if you get an early car, there may be nuances on block failures with ECU overheating on 1.6 or 1.8 engines, failures of the rear rec fuse block. Most often non-lighting stops and interior lighting are connected with failures in it. CIM failures are also probable. The switching unit of the dashboard and paddle switches. In this case, the car loses the keys, does not start. There are failures on the cushions, steering position sensor, related systems. Fail, the dashboard fails, confusing readings. In short, there are chances to stay in a freezing car in winter in the woods. Over the years, CIM modules have become more reliable. At the same time they learn to bind second-hand ones, not only new ones, which radically reduced the severity of the problem. For some inexplicable reason, right-hand drive English cars, Vauxhall, have better quality units, and there are almost never any problems with them. Cars manufactured in 2002 to 2003 with CIM block version XR, the version of the block can be seen on its end. Just turn the steering wheel and look in the gap between the steering wheel and the column, top left, should be avoided, or immediately budget $150 to $300 to replace the block. Well, or, if you want a reliable solution, $300 to $500 to replace the block from the restyling with accompanying replacements of the steering wheel, stereo, screen, climate block, and wiring harness. If to leave CIM behind brackets, in the list of typical problems there are breakage of an overrunning clutch of the generator and a relay regulator, at runs over 150, capricious wiring to EGUR, bad sealing of all connectors, and also salon and rear fuse blocks. The keys themselves are not very reliable, but now they have learned to pick up new ones and resolder chips with a mobilizer code. GM's diagnostic software is mediocre, and even the dealer Tech2 scanner, most of the services specializing in the brand have it, and many fans, is not particularly convenient to use. The community of GM drivers is smaller than VW's, and accordingly, there are fewer available firmware and coding options. The car's body is welded and painted quite well and, with the exception of a couple of weak spots mentioned above, is fairly trouble-free. The only pity is that the car is not a premium. The residual value is not so high, which makes investments not always justified. As a consequence, most of the Vectra's body problems are due to a lack of adequate maintenance. As for electrics, it will be most reliable not to contact with pre-restyling cars, well, or to diagnose them very carefully. And in any case to have some reserve of money for repair. In the next section we'll be looking at the chassis, the transmission and the engines. In conclusion, The Opel Vectra C, while a popular choice for many drivers, does have its share of weaknesses, particularly concerning the body and electrical systems. Common issues such as rust in specific areas and electrical malfunctions can significantly impact the vehicle's performance and longevity. If you're considering purchasing a Vectra C, it's essential to be aware of these potential pitfalls and conduct thorough inspections. By understanding these weak points, you can make a more informed decision and ensure that your driving experience remains enjoyable and trouble-free. Thank you for watching, and be sure to stay tuned for more insights on automotive topics.